Now let's compare a normally closed 3x2 directional control valve with the previously discussed normally closed 2x2 directional control valve. Both valves block passage from 1 to 2 in the deactivated state, and when manually activated by an operator, move to an open position, allowing flow from 1 to 2. At first glance, they might seem indistinguishable from one another, but don't be fooled by the superficial similarity in function. The key difference is the exhaust on port 3. In the deactivated state, a normally closed 2x2 valve allows no reverse passage from 2 back to the external environment, whereas a deactivated state of a normally closed 3x2 valve does. Depending upon application, one might choose one valve or another. For example, one might use a normally closed 2x2 valve to isolate one leg of a pneumatic system from another. However, it's not a good choice for actuator control. For example, a normally closed 2x2 valve could be used to extend a spring return pneumatically extended single acting cylinder. However, once extended, it wouldn't retract, even in the deactivated position, because pressurized air remains trapped in the cap end of the cylinder. A normally closed 3x2 valve would probably be a better choice. In the deactivated state, the cap end is exhausted to atmosphere, allowing the spring on the rod end to retract the cylinder. In the activated state, the valve allows pressurized air to enter the cap end of the single acting cylinder, and the cylinder extends. When an operator releases the push button, the valve returns to the deactivated state, dumping the cap end to the atmosphere, allowing the spring on the rod end to retract the rod. Let's take a closer look at this particular push button operated 3x2 normally closed directional control valve. We can see the muffler on exhaust port 3. I really like this particular directional control valve because it's rather easy to customize. We look at the valve body from the side, we can see how the push button operator interacts with the spool. In the deactivated state, the spring offset keeps the spool in the desired position. When an operator smashes the push button, the spool moves into the open position. When an operator releases the push button, the spring offset returns the valve to the deactivated position. The way this particular valve is constructed, it's a trivial matter to pop off the push button operator and install another style of actuator, for example, a selector switch with a detent. Now you don't have to pay some homeschooled operator $7.25 an hour to stand around all day holding a push button down. Additionally, check out the writing on the bottom of the valve body. Input port 1 is labeled normally closed. Exhaust port 3 is labeled normally open. It's again a trivial matter to completely change the function of this directional control valve by popping off the muffler on 3 and swapping it out with the elbow on 1 and vice versa, and calling this a selector switch actuated, normally open 3x2 directional control valve. Can you dig it? Shoot, this valve is so radically different now, its mama wouldn't even recognize it if it walked in the front door and said hello. Compare and contrast the behavior of these two valves and a single acting cylinder. 1, the original normally closed configuration, and 2, the modified normally open configuration. The valve on the left is normally closed, and in the deactivated state, the cylinder is retracted. In contrast, the valve on the right is normally open, and in the deactivated state, the cylinder is extended. If an operator presses the push button on the valve on the left, the cylinder extends. Whereas, if an operator activates the selector switch in the valve on the right, the cylinder retracts. As I cautioned you earlier, proper interpretation of schematic symbols can save your life. In every respect, these two valves are diametric opposites of one another, and misinterpretation of their schematic symbols can have dire life-threatening consequences. 3x2 valves can also be used as selectors. For example, consider a pneumatic system served by a primary and a backup pneumatic power source. In ordinary operation, the primary system powers the circuit. In the event a primary system fails or necessitates service, 3x2 valve can be moved into a position such that the backup pneumatic source takes over. Similarly, a 3x2 valve can also be used to select output. For example, a 3x2 valve can be used to select a desired branch circuit for a single source. In ordinary operation, the 3x2 valve routes pressurized input to circuit A. When circuit A finishes the task, the 3x2 valve can be moved into a position such that the same source now services circuit B. 3x2 directional control valves can also control double acting cylinders. Consider a pair of normally closed 3x2 directional control valves used to control a double acting cylinder. In the deactivated state, both cap and rod end are exhausted to atmosphere, and the cylinder rod would float freely. When an operator pushes the push button on the valve on the left, pressurized air enters the cap end of the cylinder and the cylinder extends. When an operator releases the push button on the valve on the left, the cylinder remains extended. However, both cap and rod end remain exhausted to atmosphere and the cylinder rod would float freely. When an operator presses the push button on the valve on the right, pressurized air enters the rod end of the cylinder and the cylinder retracts. As previously, when an operator releases the push button on the valve on the right, the cylinder remains retracted. However, both cap and rod end remain exhausted to atmosphere and the cylinder rod floats freely. What happens when an operator presses both push buttons? Pressurized air is routed to both cap and rod end. More area on the cap, less on the rod end. The cylinder extends, although it does so with a reduced force because the rod end acts in opposition to the cap. If this seems a little wasteful to use two valves to control one cylinder, you got a point. For this reason, manufacturers offer other types of valves with increased functionality. Consider a 5x2 directional control valve. 5x2? Some of you might be like, wait, what? Why are you skipping from 3 to 5 without talking about 4? Trust me, after we discuss 5-port directional control valves, I'll explain why 4-port directional control valves aren't nearly as popular in pneumatic systems. This particular 5x2 directional control valve has 5 ports, 1, 2, 3, 4, 5, and 2 positions, a deactivated and activated state. It appears to be lever operated. A spring offset on the right-hand side pushes the spool into a deactivated state, whereby pressurized flow at 1 is routed to actuator port 2, and actuator port 4 is dumped to exhaust port 5, and port 3 is blocked. When an operator actuates the lever, the spool moves into an activated state, whereby pressurized flow at 1 is routed to actuator port 4, and actuator port 2 is dumped to exhaust port 3, and port 5 is blocked. This particular 5x2 directional control valve would be a great choice for controlling a double-acting cylinder. In the deactivated state, pressurized flow at 1 is routed to actuator port 2. Pressurized air enters the rod end of the cylinder. Actuator port 4 is dumped to exhaust port 5. The cap end of the cylinder is exhausted to atmosphere. The cylinder retracts. When an operator actuates the lever, the spool moves into an activated state where pressurized flow at 1 is routed to actuator port 4. Pressurized air enters the cap end of the cylinder. Actuator port 2 is dumped to exhaust port 3. The rod end of the cylinder is exhausted to atmosphere. The cylinder extends. When an operator releases the lever, the spring offset valve again returns to the deactivated state and the cylinder fully retracts. In this fashion, a single directional control valve fully extends or fully retracts a double-acting cylinder based on the actuation state of the manually operated lever. Before we continue on, it's probably a good point in this lecture to discuss port numbering and naming conventions. The observant among you might be noticing a pattern. 1 is always pressurized supply input. 3 and 5 are always exhausts. And 2 and 4 are always actuator ports. Evens on the top, odds on the bottom. This is not a coincidence, and most manufacturers follow the standard naming convention. Most. You might encounter some manufacturers or older valves employing letter designations for the ports, as is common in hydraulic valves. Port 1, the pressurized input, might also be called P. Actuator ports 2 and 4 might be called actuator ports A and B. The letter designation for exhaust ports varies widely. They may be called E, X, or R. Don't ask me why it's R, I don't know. Additionally, they may be called XA and XB, or EA and EB, or RA and RB, indicating which particular actuator port is being exhausted to the atmosphere. You'll recall a lot of hydraulic directional control valves use this letter designation PT, A, and B, pressure, tank, A and B actuator ports, so it's pretty understandable. The one variation being, rather than a single T return connection, as is common in hydraulics, most 5x2 directional control valves have independent exhausts for each actuator port. Which brings me to a point where I can explain why 4-port valves aren't as common as 5-port valves in pneumatic systems. As you'll soon learn, actuator speed control in a pneumatic system is a serious pain in contrast to a hydraulic system, principally because the power transfer medium of choice central to pneumatic systems, air, is compressible and occupies different volumes at different pressure and temperature conditions. This means actuator speed control via various flow control methods is a pretty involved task for pneumatic systems and often necessitates access to both upstream and downstream, i.e. pressure and exhaust, for independent actuator ports. Long story short, ports 3 and 5 might not be directly exhausted to the environment, and accessory components might be between the directional control valve and the actuator or exhaust. For now, just realize a 5x2 directional control valve, i.e. a valve with independent exhausts for each actuator port, sure makes it a lot easier to meet these challenges, whereas a 4-port valve, one with a shared single exhaust, would only complicate it. Additionally, we'll examine accessory components like quick exhaust valves in later lectures. Additionally, I should mention that actuators and springs might be numbered, where the number is indicative of a function. For example, consider a lever-operated normally closed 2x2 directional control valve, where 1 is again our supplied input and 2 is our actuator port. This directional control valve might have 1 0 on the offset spring and 1 2 on the lever. 1 0 on the offset means 1 is blocked, i.e. the deactivated normally closed state asserted by the offset spring, where 0 essentially means blocked. 1 2 on the lever means when the lever is actuated, 1 is passed to 2. Similarly, consider lever-operated normally closed 3x2 directional control valve. It might also say 1 0 on the spring and 1 2 on the lever, again meaning the offset spring blocks 1 in the deactivated state and the lever passes 1 to 2 in the activated state. In contrast, a lever-operated normally open 3x2 valve might say 1 2 on the spring and 1 0 on the lever, meaning the offset spring passes 1 to 2 in the normally open deactivated state and the lever blocks 1. In keeping with this standard, the actuators on a push-button operated 5x2 directional control valve might have the following numbering: 1 2 on the spring offset and 1 4 on the lever, meaning the offset spring passes 1 to 2 in the deactivated state and the lever passes 1 to 4 in the activated state. After some repeat exposure and practice with a numbering system, you won't even need the schematic symbol to determine a valve's function. This being said, the schematic sure helps out. Lastly, let's take a look at 3-position directional control valve. The previous example featuring a 5x2 directional control valve controlling a double-acting pneumatic cylinder was limited to 2 choices, either full extension or full retraction with no midpoint option. A 5x3 directional control valve allows this increased functionality. Consider a double solenoid actuated 5x3 directional control valve spring-centered to a closed position where all ports are blocked. If we were to hook this up to a double-acting cylinder in the following fashion, the closed center position, when neither solenoid is energized, would lock the actuator in place with the blocked ports. If solenoid 1 4 on the left-hand side is energized, it would move the spool to a position whereby pressurized flow at 1 is routed to actuator port 4. Pressurized air enters the cap end of the cylinder, and actuator port 2 is dumped to exhaust port 3, and the rod end of the cylinder is exhausted to atmosphere. The cylinder extends. Whereas if solenoid 1 2 on the right-hand side was energized, this would move the valve to a position whereby pressurized flow at 1 is routed to actuator port 2, and pressurized air would enter the rod end of the cylinder. Actuator port 4 would be dumped to exhaust port 5, such that the cap end of the cylinder is exhausted to atmosphere. The cylinder retracts. Again, when neither solenoid is energized, the 2 centering springs on either side of the valve push the 3-position valve into a closed center position where all ports are blocked. In this fashion, a system could partially extend or partially retract the cylinder with solenoid 1 4 or 1 2, and then deactivate it at the appropriate time to hold the cylinder in a locked position midway between full extension and full retraction. The blocked actuator ports 2 and 4 ensure the cylinder remains in this position, albeit with a little spongy give common to pneumatic systems. Other types of center positions exist. If locking an actuator in place isn't the best choice, one can also make use of one type of a float center, whereby actuator ports 2 and 4 are both exhausted to atmosphere. The behavior of this 5x3 directional control valve with a float center is otherwise identical to the closed center, the one exception being in the deactivated state, the cap and rod end are open atmosphere, which allows the rod to float, hence the name, freely. This could be handy if an operator had to manually position the rod for some variable size load. As with the previous 5x3 directional control valve, you'll note 3-position directional control valves necessitate not one offset spring, but rather 2 centering springs to assert the deactivated state. All right, that is that. We'll examine air-piloted pneumatic directional control valves and more in later lectures. In conclusion, this lecture examined pneumatic directional control valves. We learned a directional control valve stops, starts, and changes airflow direction in a pneumatic system, ultimately influencing the direction of a pneumatic actuator. We discussed ports, positions, and actuation methods, and examine simple applications of 2x2, 3x2, 5x2, and 5x3 directional control valves in pneumatic systems. Lastly, we discuss port numbering schemes common in pneumatics industry. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your lazy lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.